Hi ladies and gentlemen, this is Mr. Green and this is the recording for lesson 1.02 in semester B of geometry. So let's look at what we're looking at. We're going to be looking at three-dimensional objects. Three-dimensional objects. Three-dimensional objects have to be represented in two-dimensional space. So if you're looking at a cube and you're trying to look at that in a three-dimensional space, you have to be able to draw it in that space somehow so that you can recognize it. This is called an isometric drawing. And what we're looking at here is a patty paper or isometric paper. What I'm going to do is I'm just going to draw lines. And you can see how I'm going from these points and I'm connecting these points together. Now, the ones that are off and aren't in a direct alignment, those are the ones that are trying to show the depth of the object. Okay? You can see I went 2 units in both directions. Now, if I go back up again and over, I wind up with a picture of a prism that I have drawn. Now, a lot of people say, well, we should put the other portions in there that are not, you can't see. And those would be like this. And typically they're represented with little dashed lines. But my drawing here won't let me do dashed lines. So I'm putting them in a little bit lighter weight line. Now, you should be able to see a cube sitting there in front of you. Or at least a three-dimensional shape sitting there in front of you. And there are certain faces on this shape. Okay? So we've got this blue face, which is right here in front of you. And we've got this pink face, which is this side over here. And we've got this orange face, which is the top up here at the top. Okay? It's just like having three different sides of that object that you can see in this isometric drawing. That's the way isometric drawings are typically, that you can see multiple faces, but you can't see the whole thing. The rest of them are all hidden back behind it, or back behind it in some sense. Okay? So a perspective drawing is one that's done the same way, except that we'll have a point that we call out here the vanishing point. It's on the horizon. If I extend each one of the corners of this particular square out to the vanishing point like this, it's like the object disappears at that point. It no longer exists. But what we would be doing is we would be saying, well, it's only this deep. And so we would draw a line here like that. And it looks like the object is going away from you. And that's the way a vanishing point object is drawn. In this particular situation, what you would do is then take these vanishing point lines and you would shrink them back down to here. Okay? Oops. Grabbed the wrong tool there. Like that. And you get the idea. Like that. Now, there's my object that I was drawing, and it kind of vanishes off into space. That's what you're looking for, is that it looks like it's vanishing that direction. This is something that's done quite frequently in art. You have a horizon with a vanishing point, and everything kind of disappears off into that space. Okay? Well, another thing that we need to be looking at when we look at three-dimensional objects is where two-dimensional objects had space that they took up. Well, a three-dimensional object has multiple faces, and these multiple faces each have an area or space that they're taking up. And we call that space the surface area. What I like to think of it is, if I had a box like this, and I had a Christmas present in it, and I wanted to wrap that present, then the wrapping paper would be the surface area. That's how much goes around the outside. If I have other objects, I'll be using other types of analogies, but basically it is the space that the object that is on the outside of the object on all the sides. So if we said that this object was a 3 by 4 by 8. The front of it here is a 4 by 8. And I multiply 4 times 8 to find the area of that object. And what I get is 32. So that's 32 units squared. Now the back is going to be exactly the same here because of the type of shape that I have, units squared. The left side, this side back over here that we can't see, it's kind of hidden behind it, it's a 3 by 8, and 3 times 8 is 24. The right side over here, well, it's the same as the left side, so that'd be a 3 by 8, that'd be 24. The top is a 3 by 4, that would only be 12. And the bottom is going to be the same, 12. So my total surface area is just the sum of all these numbers. So I got 2, 4, 8, 12, 14, 16, carry your 1, 4, 7, 9, 10, 11, 12, 13, 136 units squared. And it is square units, okay? It is just like finding the area of an object, of any object that we found area of. So in this particular case, it's going to be 136 square units. So if I want to find the volume is how much space is on the inside. The way I analogize this is if you look at a swimming pool, the pool itself is surface area, but the water that goes on the inside is volume. If you look at a box, the wrapping paper on the outside is surface area. The air on the inside is volume. So if I use the same dimensions on this one, to find the volume, we actually multiply the three numbers together. 3 times 4 is 12, times 8 would be 96. So it would be 3 times 4 times 12, and we get 96. But since I multiplied three things together, it would be 96 units cubed. It's cubic units in this situation. Okay? So, in case you're new to my courses, this recording is intended to help you with 1.02 and 1.03 lessons, okay? When you're sending me K-mails, when you're sending me emails, the one thing you want to make certain you do is tell me that you're in geometry and what section number of geometry that you're in so that I can find your records quickly. A lot of times you're asking me questions about a particular quiz or you're asking questions about a particular thing that I need to look at your grade in the grade book. If you tell me you're in geometry and what section number you're in, it helps me find your records quickly and it helps with the communication. It really does. Okay? So I appreciate it. I look forward to seeing you in Class Connects, and we will talk next time.